So we have the web API, and then in the Copilot chat are basically the meat of the operation. So if you take a look at the controllers, if you're familiar with just like ASP.NET applications, you'll know that controllers like are what handle the API. And by looking at each of the controllers, you can kind of get a good idea of what APIs are enabled and the route that each will take. So for instance, if we take a look at like the bot controller here, this handles like upload bot operations and stuff like that. So you look at the first function, there's like the upload async. And if I were to make an HTTP post request to this bot.upload, the controller would route it to this function, which would then handle the request. And each of the controllers are named by the domain they're meant to handle. So you should be able to just like kind of like parse through each one pretty easily. And they're responsible for processing the request, the input, invoking the right services, and then returning the appropriate response. Let me think. Another thing that the controllers do are they register any skills that weren't added when the kernel was instantiated. So like when I was showing that program.cs file, I showed that like some skills were registered whenever the kernel was initially spun up, but these controllers, like depending on the action that they're handling, they can also register additional skills to the kernel to be used in like downstream. And that includes like registering the skills for the planner. Oh, sorry, Alex.
No, that's great. One question that has come up from office hours and elsewhere is this idea of should a developer create a long-running kernel or like multiple and many short-lived kernel instances that spin up and tear down. So I guess, do you have any thoughts, or maybe from Copilot Chat, what is being done here?
So for Copilot Chat, we actually spin up a new kernel every time. And this just helps maintain the state per request without like worrying about like data like flowing between a kernel instance that wasn't meant for one request. Does that make sense?
Yeah.
So that's like the standard that we set. And like we found like that's been like the easiest way on maintaining the proper context for each request that comes through. We just spin up the kernel, give it the context that it needs, fulfill the request, and then send the response back. And that's like the shelf life of that kernel instance. And then for the next request, we will do another one. So you don't ever have to worry about like running into like the kernel running into an infinite loop, because each instance is its own standalone kernel.
Oh, that's good. That speaks to our messaging that the kernel is supposed to be very lightweight and
yeah.
Very cool.
Okay, awesome. So whenever like each kernel is spun up, basically like most of the requests that come through from the web app is a chat request, so generating that bot response. So this is arguably the most important controller in the web API application, and it's called to get the bot response to like any ask. For Copilot Chat, we created our own ChatSkill that handles that bot response. So like I said before, the controller is responsible for like handling the request, and then the ChatSkill is basically the series of steps that need to be taken in order to generate the prompt that we can then send to the LLM to get a very intelligent bot response.
Are we able to double click inside the ChatSkill in particular that we're using?
Yes. Okay. Yeah. So I will go into ChatSkill. It should be under Copilot Chat, and it will be under skills and chat skills and ChatSkill. So the chat controller does some like request handling, and then it will invoke the ChatSkill here. And the entry point here is chat async. And basically the TLDR of the chat async is it goes through a series of steps to generate the bot response, including calculating a user intent, using the conversation history, and any relevant memories or extracted information from additional plugins from the planner. But I'll walk through that like more in detail now. So when a chat request comes in, it goes to the chat controller, and then the chat controller, depending on the request, will usually send it to the ChatSkill. There's like some instances that we can talk about later where it just like bails out to a static response and sends that back to the web app. But this ChatSkill will generate the intelligent response. So let's walk through it now. So you can see the one that comes in is just like you get the whole semantic kernel context, which is a core concept of semantic kernel. It's like the ask comes in as the context, and like the highest level of the context is the ask itself. So in this case, the user input to the chat, and then the remaining part of the context is the variable. So additional information that semantic kernel may need to fulfill that request. So the first thing it does is the message is saved as raw memory for persistent chat history. And this is kind of your standard conventional database. So it's just saved as an object into this database. And chat messages can be stored in the database of your choice. And Copilot Chat currently supports file system, volatile store, and Cosmo DB. And you can configure all of that in the app settings of the web API, which I'll show you guys. It's at the top level of the web API folder, but that's just where you can configure your different settings for your semantic kernel there. Let's see. And then the chat, the chat message can be one of three messages. So it can be a regular chat message, which is just like the ask that comes in from the chatbot. It can be a plan that came back with some user action. So if it was approved or rejected, and then it could also be a document upload. And ChatSkill handles each one of these a bit differently on how to generate the response. But right now we'll just go through like the normal flow, which is the regular like chat message flow, because that's kind of like what most of them follow. So I'll continue on the chat skill, and then we can kind of dive into how the chat response is generated specifically. But once the response, so basically like it tries to determine like what kind of message it is, and then it will go generate the response, which is basically like generating the prompt and then sending it to the LLM and then getting it back. But once this chat response comes back, the bot message is also stored as just like a raw content message for persistent chat history. And again, that's the conventional database. And then down here, sorry, the message also can generate a new memory. So like basically like what memories are they're represented as embeddings, and memory items are saved in like isolated collections based on their memory type. This chat app currently has three different kinds of memory. So we have long-term memory, working memory, and document memory. And memories are stored in the vector database of your choice. Again, another core semantic kernel concept. And this app currently supports volatile, quadrant, and I think Azure Cognitive Search, but it can be like easily extended to like whatever vector database that you want. If you're unfamiliar with embeddings and vector databases, I know we have like some pretty good documents on it on the Microsoft Semantic Kernel Learn website. But in short, like you can kind of think of like memories as this summary of the chat history. And chat messages are generally stored as both long-term and working memory, where working memory is kind of in like a shorter time scope, and then long-term is in like a longer time scope. So memories are only saved if there's not already another memory item in the memory store that has a like high similarity value with the message that's coming through. So that's in memory in short. So once it's saved to the chat history database, the response is generated, and then the memory is generated, we send the response back. And that's what the user sees. So that's the chat skill so far. I'm about to go into the bot generation flow, but I'll stop here. Do you have any questions, Alex?
I don't have any. This has been very clear so far. Thank you.
Okay, cool. Cool. Now we can find this. So this, so like I said earlier, we have some responses that are just static. Like for instance, if if a user got a plan and just decided not to run that plan and hit cancel, we'll just return like this static response. It has to come through so we can save the message in chat history, or else you could just do it on the front end. But like that's why it has to hit the web API first, and then we return the static response and save that as the bot response for whenever you load chat history. But for all other cases, it hits this like get chat response async method, which is still in the ChatSkill. So basically, the bot response is the LLM's response to a very carefully constructed prompt that uses like the user intent, the context variables, and other information that I'll walk through. And what this method does is it generates each part of the prompt before sending it to the LLM for the LLM to figure out what the response should be. It's an execution of both semantic and native functions. So this is the general flow that it takes. So this first one, it gets the audience, and the audience is basically just all the users who are part of that specific chat session. And this is done using a semantic function that considers the chat history and uses the LLM to extract different actors from the chat history. And then it will try to extract the user intent from the conversation history. This too is done using a semantic function, and it considers the message and the conversation history. So this just kind of like puts the user's ask into a more like defined words that makes it easier for the LLM to understand like a specific goal. And then
So-
that's oh, go ahead.
So a question that I have is for any given chat message, how many calls to the LLM are being made?
Okay, we can count this once you go through. So
Yeah.
do you want to keep count as we go through? So there's 1, 2 right there. Yeah, so we'll have that answer later because I don't know off the top of my head.
Okay. Yeah.
Yeah. And then so those two are pretty much like the static components of the prompt. Like you'll always need the audience and the user intent. And then from there, the function, this like get chat response function will just invoke additional skills that will build on the rest of the prompt. One thing to note is like,
Okay.
yeah.
Go ahead.
I was like, one thing to note is like this ChatSkill is also responsible for token management. So you can set the token limit for like completion endpoints, which is what's used to generate the bot response in the app settings config file. And it will take that as like the baseline. And then from each one, what this get chat context token limit method does, it basically subtracts the amount of tokens that each part of the prompt is taking up. And then for the rest of the functions, we have allocated percentages for the remaining token budget that each section can take up. So that's all done within the ChatSkill.
Yeah,
Okay,
this was my question. We had a good discussion in a previous office hour about token management, token limits. So it's very good to see, I guess, how it's exactly handled here in Copilot Chat.
And so, like I said, the audience and the audience and the user intent are take up their own amount of tokens, and we don't limit that, like because they're usually like a small amount of tokens. But let's see. Yeah. So for the prompts here, you can see that the chat skill prompts are used to generate the responses, and the completion token limit is the limit for the chat model. So this is the initial limit that the chat skill asserts on the prompt that it will send to the LLM, and this can be changed to whatever dev is spinning up this web API before you run the application. And let me see if I can find an option. And then in prompt options, this is basically like the config file. You can see like the weights that are assigned to each one of the sections. And again, like this can be tweaked to the dev's like personal preferences. But in general, like the memories will take up like 30% of the remaining token budget after the user intent and the audience have already been accounted for, document context, and external information context. So this is kind of important on whether like you want to make the memories, like the chat history, more contextual in the bot response, or if you want to take more of like the external information, if you want to give that more weight. Okay, so that's basically how like token management is done. And then the next step from there is the ChatSkill will invoke the planner to see if like a plan is required, like if external information outside of whatever data the LLM was trained on. So that's like, this is what happens here. So as of today, you can use the action planner or the sequential planner. And the action planner is basically a single step planner where it will find like the one function that it thinks is the best to fulfill the request. And then sequential planner can plan multiple functions that are available in the kernel to fulfill the request. Right now it defaults to action planner, but you can turn on sequential planner in the app settings config. All right, so how does this work? Let's go to this. So ChatSkill has another function called acquire external information async, but what this function actually does is it invokes another skill, which is the external information skill. And this skill pretty much handles all of the planner functionalities. And let's see if I can get to it. Okay, cool, yeah. So the external information skill, it's also in the same like directory as the chat skills. But this method is the entry point for handling the planner with a chatbot response. And if the request is just a regular, we'll come back to this later, but if the request is just a regular message, then the skill will invoke the planner to see if there are any relevant functions that can be used to fulfill the user intent. So like I said earlier, the planner and the kernel that this request has been running through are completely separate, but the planner has its own kernel. And it's basically like we copy over the context of like the currently running kernel into the planner's kernel. So it has context of all of like the skills that are available, the functions that are available, and any variables that might be relevant to the ask. And the planner will then decide, we'll take all of this context with the goal, which is the user intent, and send it to the LLM. So that's 3. Send it to the LLM and decide if a plan is needed. And then if a plan is needed, if there is a function that could fulfill the request, then the chat skill or the external information skill will send that plan back to the chat skill, and the chat skill will just bail out at that point, bail out from the bot generation and just send that plan back to the user for some user action, which is getting approved or rejected. If the planner determines that no plan is needed, so the planner in this case is like talking to the LLM and the LLM can return like an empty body, that means no plan is needed, no function was found to help fulfill the user request, then the external information skill would just return an empty string and thereby adding nothing to the bot generation prompt. So does that answer your question from earlier, Alex, on like
Yes.
how a plan is used? Okay,
Yes,
cool.
it does.
All right, so while we're here, if the original message, like I said earlier, like it could have been a plan, a regular user message, or a document, if it was a plan that had come back, it would have followed through all the same steps until it hit this step. And in this step, if the plan has already returned to the client, is now being returned to the kernel with some user action. So the user approved it or the user rejected it, then the planner will see that like the user approved this plan and it will run this plan instead of trying to generate a new plan. So I'll take that plan, we have to like reload it with the context so it knows the current context of the kernel. And then the kernel invokes the plan. So you can see that the planner isn't part of this execution. The kernel is the one that executes the plan. The planner just creates a plan. So the planner basically like it's introduced the capability to run additional functionality. So like from these plugins over here from Copilot Chat, whenever you enable these, you're basically enabling each one of the functions that are tied to each one of these plugins. So Microsoft Graph, which is like sending an email, adding a task, GitHub, interacting with your pull requests and the data there, Jira and Klarna. And so the external, like the plan lets you do all of these additional operations that aren't readily available to the LLM at like face value. So once that plan is executed and the data comes back as a result of the plan will do some like response transformations, since some of these are like API requests and the response that comes back can be like huge JSONs. So it will take care of that for you. And then it will return the result as a string that will be concatenated to the larger bot generation response.